So welcome also from my side. Hope you had a nice break and are ready for the last stretch of today. By now, you should be very familiar with our principles of Checkmk. What I want to dive into now is the alerts and analytics part of Checkmk. We did a lot in 2.4, and we want to continue down that route for 2.5. If we look at how you get an insight into your monitoring, into your IT, there are various ways with Checkmk. You have views, you have reports, you have notifications, but the overwhelming majority of you is using dashboards. Over 80% have some sort of dashboard in place. We offer two different kinds of dashboards, the built-in dashboards and the custom dashboards. And here again, most of you are actually using both kinds. But if we look into details, this is only part of the story, because the custom dashboards, they are not so custom. Usually what you do is you just clone a built-in dashboard, adapt it to your needs, and then we call it the custom dashboard. But why is that? Building dashboards in Checkmk is not the nicest experience. I don't know who hit the 7 here, by the way. Apparently somebody is actually good at it. But let's have a look at how it actually plays out in reality. So let's pretend we're building a dashboard together. We just try it, and we click on the Create Dashboard, and then we end up on this page. The first thing that we see here is an option that is like specific objects. I mean, I don't really know what it is, so let's just continue. It's probably not important. Then we end up here, and the next thing is I need to select some filters for the dashboard. Yeah, I don't know why my dashboard needs to be filtered at this point, but let's just pretend also that this option doesn't exist, and we save and view. OK, I end up on an empty page. This is what I would have expected from the get-go. And the empty page, let's fill it with some stuff. So I press Add. And if I press Add, OK, what do I want to add? So some sort of a metric. Then I'm greeted with several things. Single metric graph, performance graph, custom graph, combined graph. I mean, I want just to have a graph, and I just choose the first one because it's the first one. Probably there's a reason for that. And then I have the time series. I didn't expect to end up now with the time series because I pressed something else, but here's the time series. And this is basically where now things start to make a little bit more sense for me. I have here also the host and service filters. I mean, for a metric, I'm now a little bit more familiar with that. So I can select the specific host. And after that, I can then also select the specific service. And because as Checkmk, we're nice at configuring stuff, we also can now select the metric base for that particular service. And then we end up here. Probably this was the worst way to show a single metric in Checkmk, because there are far easier ways to do that. But at least we have now added something like a custom dashboard. But this dashboard isn't really useful because it just gives you an insight into a single metric, and you could have done this far easier. Now, let's build a proper dashboard, because dashboards are powerful, and at this point, we want to actually use all of the magic. So for the title of that dashboard, here we are able to use something like a macro. So the description of the dashboard and the title of the dashboard actually adapts to what I select later. Because I want also now to make use of filters, I deselect the service description filter, and at this point make the dashboard far more powerful by doing that. If I now basically press save, I end up with a lot of very ugly error messages, because now my dashboard cannot be rendered because I haven't selected the filter. If you're at this point, you might ask yourself, where do you now need to press? And obviously, it's this button, because you need now to select the filter for the dashboard. We deselected it previously for the time series graph. Now for the complete dashboard, we can select the filter that applies to all of the elements. Makes sense so far. If you don't know this, then good luck finding it out. Now we have selected the filter, and all of the graphs start filling with the correct data. And actually, this is where filters really shine. They are super powerful, because I can just select also a different filter, and now all of my graphs adapt to that different filter. So overall, I didn't build a single dashboard. I built actually like thousands of dashboards with only a single template, because I can select a different filter, and with the different filter, the dashboard will adapt accordingly. But filters are complex. If you try to find the correct filter for your use case, it might prove difficult. And if you think these are a lot of filters, press this button, there are even more. Now, what we want to focus for 2.5 is make this whole experience easier. Easier dashboard creation. The first part is the dashboard itself. Here, the dashboard properties that I have shown at the beginning, we want to touch them, make them far easier to configure, and also far easier to understand what you're actually configuring. So the dashboard properties and the context and search filters. The second part is then what is actually shown on the dashboard, the dashlets and the graphs. Here we want to touch the graph selection, metric selection, and also how you move and resize different dashlets. One thing that I cannot promise so far is something like a preview mode that you actually see what might have been shown. But we will also have a look into that. Now, this is only basically somehow fixing the symptoms. So it's making each individual step a little bit better, but it's not really tackling the whole problem. Because the whole problem is you want to have a nice end-to-end workflow of configuring dashboards. And that is what we want to deliver with 2.5. We want to introduce something that allows you to move through a guided process of dashboard creation, from the beginning to the end, until you basically don't have to be an expert anymore to actually configure a useful dashboard. The next thing that I mentioned is filters. Filters are something that we want to reimagine how we use them. I brought two different concepts with me how this could look like. We haven't decided yet, so bear with me. But this is an idea how it could look like. For instance, something like a query language where we basically combine different aspects, like here the host status, the service status, and the host state, and then get a combined filter query out of this. This is something that we can imagine. Or maybe just make them more accessible by grouping them nicely together, by putting them into boxes, and being able to actually find the filter that you like. But what about responsiveness? I heard now quite a few times, and also speaking with some of you on the conference now, that there is a type of dashboard that is basically missing. This is something that we definitely have a look into and also experiment with it. We call it the grid mode so far. Basically a different type of dashboard that is not suitable for a single screen, but adapts based on the device that you're using it. Looking a little bit more into dashboards. So what is usually on a dashboard? What is shown on the dashboard is a graph. And actually, most of you are pretty happy with the graph usage overall. So you have different time ranges, you can have a look at different zoomings, you can pan, and so on. Even though it's not the nicest experience I have to admit, but it's okay. But there are options, and from our user service, we know that these options usually are not even known. So right now, you are even able to select the correct timer. You basically can set the beginning and the end time of what you want to see. You can zoom, you can pan. It's just hidden in the display options of the graph. This is something that we want to make far more accessible by putting it directly at the graph, because then you know that this option exists and probably also more people start using it. Now, the second part where I want to focus on is the great user experience. From our perspective, great user experience starts with speed. In 2.4, we did a lot of things to improve speed. And across the board, we just got so much faster in 2.4. Then the question remains, what do we want to do in 2.5? We could make it even faster, and we obviously try. But some things will always take time. So if you, for instance, have an SNMP device and look at the share of the different times, you will notice that Checkmk and the server, it doesn't even need any time at all compared to basically the time how long your SNMP device needs to actually answer. So there are limits to how fast we can get stuff, because at the end you're monitoring real hardware, and the real hardware will take time. What we can do is to make this whole stuff more transparent to you, to show that Checkmk is actually doing something in the background. Because right now, you usually end up guessing if Checkmk now does something. And especially for new users, this might prove very difficult if you do not know for sure. And your feedback regarding this has also been super, super clear. You basically don't know if Checkmk is responding or not. So you press the button and nothing happens. And from my own experience, I can also tell, I basically look at the loading bar and, I don't know, like at the normal browser built-in stuff to see if something is actually happening. And any information that would tell you this would actually be very, very helpful. But because you're a community, you also give us the ideas how to fix this. Something like a progress bar, something like a loading spinner, and wait for it, it will come in 2.5. At various places, we will introduce the loading spinner and make the transparency that Checkmk is actually doing something. This is also something that we want to have a look into. It's a confirmation. Because after you have waited and the loading spinner loaded, you want to know what Checkmk did, whether it succeeded with an operation or whether it didn't succeed. At least you want to know what happened. We did this in 2.4 in various places, and in 2.5 we want to elaborate on that and basically add it at more places. Something that we will also have a look into is page skeletons. So page skeletons basically like the page is pre-rendered in some way, but not filled with data yet, because the data access takes a little bit longer. But it's something that we cannot promise for sure, because it's playing around with a different technology. To summarize, in 2.5, when we can, we will fix the problem at the source. We will make 2.5 faster if we can. But if we cannot, then we will at least offer you some sort of transparency into the insights of Checkmk, what is happening and what you can expect. The next part is extensible interfaces. And here I will talk about the feature. It is probably the most used feature of Checkmk overall. Most of you already know I'm talking about the REST API. And for the REST API in 2.5, we have big plans. You already see this here in the URL if you have a look at this particular number. It says 1.0, so it's already some sort of a version of the REST API. Now let's have a look at the evolution of our REST API across the last few years. We introduced it in 2.0 with the REST API 1.0, and we kept the 1.0 ever since. Over the time, though, we did a lot of changes to the REST API. We introduced new endpoints, we changed endpoints that were already there, and we also deprecated stuff and added other stuff. So overall, the feature depth that we have increased significantly. Also, what we did is we increased the stability along the way. And today, we're at the point where we say the stability is good enough that we are confident we can introduce some kind of versioning without introducing too much fallout. So just version the API. Checkmk, unfortunately, is not your normal web service. We have differences compared to others that make versioning our REST API far harder than versioning of the normal web API. So how are we going to tackle this? If we look at versioning, there are two ways how we could do the versioning itself. Here we specifically decided to use a top-level versioning approach. This might, at the beginning, seem a little bit weird because it makes versioning for us much harder. But this is actually something that we consciously want to do. We want to make versioning for us harder. Every single time we will introduce a change that might break the API, it means that we need to do a very careful consideration if this is actually worth it, and that is why we chose the top-level versioning. We want to make our life harder to make your life easier. If I ask my developers, usually there's only one way to do versioning. It's semantic versioning, and that is also what we will use for the REST API. However, we will not expose all of the versions in the calls to your scripts. The reason for that is quite simple, because you do not want to adapt the script every single time we adapt, for instance, a patch version or a minor version. So at this point, we will only expose the major version in the script, so whenever you have the script that actually keeps working if we update the API. Now come with me, we do now a little bit of a deep dive into how this versioning plays out across multiple Checkmk versions. If we start at 2.5, we will introduce the version v1 of the REST API. Across 2.5, we will probably add new endpoints, we will probably patch some features, and the API will keep evolving until somewhere in the middle of 2.5, we might introduce a breaking change. Because stuff happens, and at some point it might be necessary. But then we at least say that for the complete lifetime of 2.5, we will support all of the APIs. So the v1, we will not deprecate v1, we will actually support it until the end of the lifetime of 2.5. So with the v2, and if at some point we might become fancy and say we now need the v3 because we do another breaking change, then we will also support v3 until the end of 2.5. The updating between versions is what gave us a little bit of a headache, because we want to make your life also here super easy, and this is the approach that we came up with. So the last version of 2.5 will actually have several active versions of the REST API, most likely, maybe if we're good, only one. But at least the last version, v2, will be the basis for the REST API of 2.6, which means the update procedure is actually quite simple. On the last patch level of each version, you need to update your scripts to the newest available REST API. And at that point, you just trigger the normal update of the REST API, or not of the REST API, of your Checkmk version. And the v2 will remain unchanged in 2.6, which means that during the normal upgrade, we don't experience any problems. And after that, the journey just continues with 2.6. To make it a little bit easier for us, after we have done a major new version, we will not do any breaking changes in old stable versions. So anything that might require a breaking change will only be done on the newest version of Checkmk. Now, if we take a look back at our monitoring platform, behind the scenes we have done a lot. We have done a lot to improve. We have done a lot to enable our engineers to build the best features available. Usually, you see what these features are, but below that, a lot is happening behind the scenes to actually make them possible. And in 2.4, I'm super proud that we introduced a new platform for features. And now I give you a little bit of an overview. What of the features that we showed you across the last 2 days were actually built on that new platform. The first one is the guided configuration. Something like the quick setup for AWS, as we saw, is built on the new platform. The second one is like a feature like a slide-in that we now use for the notifications. And I spoke to some people, you're quite happy about it. Also, this was enabled by the new platform. Something like an in-page validation, where you basically know directly at the source where your problem in your configurations are, is powered by the new platform. As well as something like inline help that is actually at the right place using tooltips. Now, this is a foundation that will enable us to deliver features across the UI and Checkmk over the next few years. We stepped into a real front-end implementation of our ecosystem, and we built an interactive UI based on that. It will enable dynamic page rendering, real front-end code, and at the end for you it will enable a much, much better user experience and faster interfaces. And it has arrived, at least partially. So we built the new UI platform, and obviously it will evolve over the next few years. And you already know now some of the features that we have built new upon this new platform. At the same point, we also started already migrating things from our current way of doing things to the new platform. One of the examples is, for instance, the app connection page of the DCD. There you can already see how the new platform looks like. In 2.5, we want to continue down that journey. One of the things that we will have a deep look into is the custom graph editor. Also there we will use the platform. The editor itself and the custom graphs, they will become much, much more important because of the new metric backend and the OpenTelemetry integration. Something that Martin already showed is the activate changes slide-in, and also this is powered by our new platform. The host validations, something like the spinners or maybe the skeletons, all of this will be front-end implementations. And last but not least, hopefully new rule sets everywhere. This is a gigantic task, but it will enable us to move away from a lot of technical debt that we have and will allow us in the future to do in-page validation everywhere. And now I'm heading over to Lars, who will tell us a little bit more about the probe.
So, hello again. In this next section, it is about a brand new component we are about to introduce with the next month, which enables a key use case for our SaaS customers. It is for monitoring segregated networks from the SaaS environment. Our typical approach to this is to deploy Checkmk remote sites in your segmented network. It is for the local monitoring in this network. And if you want to integrate that in your distributed environment, you have to open up something, some network port in your firewall, for example, to enable the integration with the central site. But reasons for doing this, doing distributed environments, are different for users. Can be performance. You need more power in your monitoring than a single machine can provide. It can be organizational reasons. You want to have different groups of people working on a set of configuration. Can be availability. You want to have a local monitoring. Even if the uplink is down, you want the monitoring to continue working. Can be security. You want to minimize the network traffic between the network segments. Can as well be connectivity. You have low bandwidth, unstable connections, and whatever the reason is for you, we think that our approach of distributed monitoring actually brings a lot of value to you. We are quite efficient in the monitoring job when we contact systems and so on with your bandwidth. We don't consume a lot of bandwidth over the wide area network connections. We have a local, reliable monitoring. When your uplink goes down, the monitoring just continues. It does the whole job, notifications, storing metrics, and all of that. And when the uplink is up again, you don't have any data jams. And adding sites, removing them, and so on is quite easy. So we have overall a quite flexible, powerful system. But this comes at some cost. Your remote sites need a full-fledged Checkmk installation. And as I've shown you yesterday, this is quite a complex machinery. A lot of components working together, which is not easy to deal with overall. You need to have all the resources available, the compute power, memory, and so on, to run all of this. And of course, the component, they need maintenance. They need updates, they need patches from our side, and so on. And as I've shown already, you need to open up network ports to get something out of that network segment. And we think for our SaaS use case, this is not easy enough. That does not fit the idea of how we think users should work with the SaaS environment. So we are about to introduce something new, a new form of distributed monitoring, by adding a new component, the Checkmk Probe, which takes over a subset of the responsibility of a remote site. It will contact the local systems as usual, do the monitoring, and then provide the data to the central site so that you don't have to open up the network ports. And looking at the architectural view, you see a few components that we have talked about earlier, which we will use and continue using in the central site. The UI, the monitoring core, checkers, agent receivers. And we will move the fetchers into the probe. So taking something that is already there, the fetching engine with all the SNMP stuff and so on, the complex machinery that enables us to contact all the monitored devices, move it into the probe, and extend it with a new component, the scheduler, which takes over some of the work that the monitoring core typically does. The whole probe is configured by the configuration UI or the REST API. The configuration is sent down to the probe so that the probe actually does know what to do and when to do something. And when at some point the scheduler decides a host needs to be contacted, then it tells the fetcher. The fetcher gathers the data from the device and then sends over the data all the way through the uplink to the SaaS instance and so on, so that it arrives at the checkers at some point where the check results are computed. And from then on, everything goes as usual. The checkers send the results back to the core, metrics are stored, and the UI can provide you with the data. Additionally, to enable use cases like doing service discoveries, we will establish a channel from the SaaS instance to the probe so that you can send ad hoc commands. Now, if you put both approaches, the remote sites that we traditionally do, the probe side by side, you will recognize that in some key aspects, they are quite different, and you cannot really identify the best solution, the best approach. It depends highly on your needs, what fits best. And as I tell you all of this, you may also think, well, I could use this in my self-deployed environment. Would be nice to have. And I can agree with you. You're right. Yeah. We internally motivate our development with a SaaS use case, because there it brings the biggest value gain for us and also has the highest requirements. So we built the right thing in the end for this use case. Looking forward, we can very well imagine adding this feature to our on-premise variants, the cloud and the MSP edition, so that you can also make a use of it there. Coming to the next topic, product telemetry. This is actually not a feature primarily for you as a user. You will likely not see much of it. This is a tool for us, for Martin's team, to make the right decisions when thinking about what to do next in the product. We want to understand better how Checkmk is used, and in the end, want to make the right decisions to improve Checkmk in the best way possible. And we think the product telemetry can help us a lot there. So far in product discovery, Martin mentioned that a lot of times, we rely a lot on your input you have for us, your idea, your perspective on Checkmk and your job, and we do a lot to get the information from you. We do surveys, very targeted questions about what we are thinking. We take inputs from the idea portal, the forum, from Reddit, and so on. And we do as well some interviews with a selection of people on certain topics we are working on. And this is all really nice and great. We get a lot of insights from that, but this has also clearly some shortcomings. Because we are biased in all kinds of ways. We do the interviews with a selected group of people, and we make the selection in the end. Who do we talk to, and so on. Yeah? And that gives us already some influence on the outcome. Then, in the interview situation, the problem is that we talk to people which sometimes also spontaneously react on our question. They think about, oh, how was it at the point, and then we get some response, and that does not always 100% align with what actually happened. So we also have some influence there, which can bring us in slightly the wrong direction. And to make the right decisions, which have truly a big impact sometimes, we actually need objective and quantitative data to make the best decisions possible for the product. We want to understand where people spend their time in Checkmk. We want to understand which features are used the most. And we also want to understand where people stuck or slow down. Without the clarity, we are risking optimizing the wrong things and overseeing what is truly needing attention. And the third problem, we speak on the conference, in the forum, and so on. The problem is we are talking to only a tiny subset of the Checkmk user base. What is about the other 90-something% of users? Most people just make Checkmk work for themselves, happy using that and having a good time with Checkmk. And we don't know what they do with it, how they do it, and so on. And we think a thoughtfully built product telemetry can actually help us bridging the gaps somehow, so that we can make smarter product decisions in the end for all of us. So the problem with such a thing is, of course, we need some data out of your systems, which are sometimes not connected to any transport mechanism we could use. Of course, that's not easy to build in the end. We want to make some very clear and sensible safeguards here. We want to be transparent in what we collect. We want to give you all the tools that you can see, okay, this is what I am sending now. And we want you to be fine and comfortable with that decision. We want to primarily transport sanitized, aggregated data. We don't want to have any sensitive information, so we will put some work into making sure that it is fine to transport that information to us. And we will not force anyone to submit data to us. But we want to encourage you, because in the end, this gives you a voice. You can give us some information which helps us to making the right product decisions. And here, just for your understanding, some questions which we are struggling to find very clear answers for. It's very basic, yeah? Which check plugins deserve the most of our time? Where should we invest the improvement time we have? When we work on user experience, on the UI for rule sets, for example, which rule sets do you use the most? Where should we focus on? Or very basic, which screen resolution actually is the important one we should improve our UI for? For all of this and other questions, we are really looking forward to make data-driven decisions and forming answers and making good decisions for the product. Now, let's come to the next topic, extending our application monitoring offering. We approached this in actually two streams. One has been presented by Martin already briefly in the talk about the 2.4. The second one, the first one, it has actually been released in the 2.4. Yeah? You've seen this screenshot already twice, so I will not explain that in a lengthy way. You've also seen how the architecture under the hood is of that component, how that is built, so I will also skip over that and jump in here again. So the creation process of the services that base on OpenTelemetry metrics, that goes in 4 steps. We have the metrics stored, you pick them up, you make the decision which ones are relevant for you, you assign some host names, yeah, where do you want to see that created in Checkmk, then services are created, and based on that, you can put them into alerts, you can use them in dashboards, and so on. And this is what you get in the 2.4. It works, you can use it. We are happy to get your feedback on that. We deliberately launched it as an experimental feature to still have the freedom to make fundamental changes to it, to change the configuration, naming schemes, and so on. We don't have very concrete plans on this, but we wanted to have the freedom for this feature because it's very early in our development process. For the 2.5, we want to have a well-rounded, finished feature which is easy to use and feature-rich. We plan to invest quite some time into this. We have a dedicated development team working on this for quite a while, thinking about what should we do, what shall we add, and so on. How can we do it? And we really look forward to build this in close collaboration with you. So we want to understand how you are using Prometheus metrics endpoints, OpenTelemetry data. How should it look like in Checkmk from your perspective? So we have Niklas as the product owner who works on the project. He is also here somewhere. So there's Niklas standing up there. If you have any input for him on this topic, please reach out to him. He is really happy to speak with you about everything that you would want or what you miss so far. But now let's go through the list of things we think that we should add to this so far. OpenTelemetry supports a variety of authentication mechanisms. Checkmk so far supports the basic authentication. But there's MTLS, Barra, OAuth. And we want to focus on the ones which are the most relevant to you. So if you're into this and you have something on this list or something different, reach out to Niklas and tell him that this is important to you so that we really can focus. When it comes to the hostname computation, this is the configuration dialog you use. You select certain criteria, and out of that, the hostname is built. So in this case, we have as a prefix the pod_EKS_. We have configured that explicitly. And then we can make a connection to an attribute, which is provided with the metric. The identifier of that attribute is, in our case, the first one, the namespace name, and later on, we have the pod name. And this is coming from the metric that is reported via OpenTelemetry. This here is some extract. It shows the resource attributes which are provided with each metric we get reported. And which attributes you get here is individual for each metric we get reported. So in some, we have the pod name and the namespace name. And when you configure this dialog now, and you have some metrics in mind, you need to know which things are actually reported, yeah? The attributes, which ones are in which metric. If you don't have a solid understanding, can look under the hood, then it's not easy to identify. And we want to help you here with some approach. Not sure if it will be this one, but you get the idea. We want to provide you with mechanisms to make the right and easy selection of attributes so that the configuration becomes easier. Talking about the service being created and metrics. A strength of the Checkmk metric system is that we do proper scaling of the values, that we assign units automatically so that you actually get useful graphs. If we don't have this support from the metric system, then you just get plain graphs, plain numbers, which is not really helpful, of course. In the 2.5, we want to use the metadata, which is being reported with each metric, to build better graphs out of the box, and as well provide you with options to tune that, to configure the graphs in a way that they are working better for you as our users. Then, besides single metrics, we also get OpenTelemetry messages, which include certain data points, which are related to different time series. We get, for example, in this case, we get the heap size and different numbers in one message. And so far, we cannot process them and assign them to individual graphs, which we want to change in the next version. And for things like this, it actually can also be a lot of help to be able to apply mathematical operations, like summing the numbers or something. And so far, we have talked about a use case or an approach where you configure the whole logic of the services, of the way the metrics are combined, which totally makes sense for many metrics, especially custom application metrics where we don't know how to work with the metrics. But as you can see in the screenshot, we also get really basic system resource metrics reported, like the disk I/O. And when we talk about such metrics in Checkmk, you all know, you all love discovery mechanics we have. And of course, when we talk about the agent, SNMP, we do that. And there's actually not a really good reason why we should not do that with OpenTelemetry data. So it could actually make sense to make it some kind of a data source for our check plugins, which could then build, like we built on SNMP, like we built on agent data, to build on top of the OpenTelemetry and the Prometheus data, so that we can actually discover services based on that. And with all these extensions, we believe that we can provide a quite competitive OpenTelemetry monitoring so that we can help you with monitoring all your important applications. Now, there was a stream 2, and that's what we are coming to now, which is a new storage backend for Checkmk. And let me give you a bit of context to give you a better understanding for why we think that this is important. Today's modern application metrics come and go. You can have one pod that runs for a time, reports its metrics, and then the application keeps running. The pod is somehow restarted for some good reason, and then another metric assigned to another pod is being reported. Pretty usual, pretty normal today. So over the runtime, over the lifetime of an application, the metrics can come and go. And they are identified by metadata, something that I've shown you earlier. The pod name can actually change over the lifetime of the application. Here we see another example why metadata, which is being reported, is important. We get the heap size reported with multiple metrics, and we can only structure and use the data in the right way when we respect the right attributes, the right metadata, coming via OpenTelemetry. And the same is true for the data provided from Prometheus. We get a metric, some labels attached, and we need to make a careful selection of which metrics, which labels we want to work with to structure the data, to put it into dashboards, into services, and so on. So to summarize, when working with modern applications, the monitoring systems need to deal with short-lived metrics. We have these multidimensional metrics. We have identifiers which are in the metadata, which can be dynamic. On the user side, we need exploratory features, and we need flexibility in structuring the data so that it makes sense to users. So in contrast, the Checkmk monitoring, it is very focused on which data is fetched. We have an idea what we want to monitor, we fetch the data, we structure the data in services, we derive metrics from it, and then you can use everything in dashboards and so on. In this new use case, it is quite different. It all starts with a data dump. A lot of metrics being dumped into the monitoring system, stored somewhere, in a very flat structure, without idea how this is used later on. And then a system picks up the data, makes a selection, structures it into services, into metrics, to put it on dashboards, use it in alerts, and so on. And this is quite different. And if you know the metric system of Checkmk, it is pre-structured and tuned to the left use case. So to be able to cover the right use case properly, we need something new. So in 2.5, the idea is that we make a technology choice for a new metric backend that allows us to cover the right use case I talked about. We want to design the target architecture and want to do the first integration. So we have the system in Checkmk. To put some use to it, we have the graph designer, as you may know, in Checkmk, and we want to use the new backend as a data source for it. With that, you can create graphs based on the OpenTelemetry data in the way you want the graphs to be, with the data you have in the backend. And you can add these graphs to your dashboards. The OpenTelemetry monitoring will work as before, but we want to make the data storage mechanism make it some use of the new backend. Now, when we talk about metrics, of course, in Checkmk, there are the host and service metrics. And looking forward, it does not make sense to maintain two metric backends. That's two technologies, two tech stacks, and so on, quite complex. Looking from the internal perspective. And looking from the user side, it can be at some point that the one approach has certain features and the other has certain features. In the end, we want to enable combined use cases of the OpenTelemetry data, of the service metrics, and the host metrics. So the idea is that we transition somehow, that we get some experience in the 2.5 with the new backend. We have some use cases there. You can make some use of it. You can also give us feedback on how it works, how it scales, and so on. And once we're sure that we can make the transition, that we can deal with that, with the different scales of Checkmk in the right way, then we will prepare for the move of the old metric backend, the RD-based backend, to the new metric backend. And even in the 2.6, this will likely be an optional step, or at least a delayed step, so that we have a smooth transition for everyone. So, in conclusion, we are now working towards a full-stack monitoring and observability platform for the hybrid world. And we do it together with you. Thank you.